Hello and welcome to Lesson 5 in our look at learning Nobe OmniScope. In this lesson we want to talk about performance in Nobe OmniScope, and performance is broken down into two categories of operations: scope rendering and calculations. Scope rendering itself is broken down into two categories, which are pixel-based rendering, including scopes like the Waveform, Vectorscope, Channel Plot, and CIE Plot, and image-based rendering, including the Source Preview, False Color, and Snapshot. Now, calculations look at things like peak levels in the waveform, the histogram, and QC, including gamut check, HDR stats, and blanking detection. In general, especially on lower-end GPUs, calculations are more taxing on your system than scope rendering. If you experience performance issues and don't need features listed in the calculations section, simply turn them off. The gamut check, found under the QC dropdown, is a specific operation because it ignores the downsampling or scaling settings. So if you monitor 4K signals and use performance settings to downscale the image, QC gamut check will ignore that setting in order to give you precise values and work with the original 4K source image. If you experience performance issues, first disable gamut check before you try any other settings. Let's talk scope specific for a second. As I mentioned before, the histogram is one of the most taxing scopes on your system, especially for lower end GPUs, as it is a pixel-based scope. When it comes to the Vectorscope, the split highs, mids, and lows Vectorscope is, obviously, more GPU intensive than a single Vectorscope, and when it comes to the pixel-based scopes, CIE Plot is the most taxing on your system, so keep that in mind. Most of the pixel-based scopes feature the option for enhanced rendering. On most systems, enabling enhanced rendering actually improves overall performance. There are some specific GPUs that is not the case though. If you experience performance issues, it's worth checking if enabling or disabling it improves the overall situation. So let's talk about settings that affect performance. Most of the performance settings can be found in Options, Preferences, Performance. It's always best to set everything for maximum performance, and if you notice any issues, you can adjust your preferences from there. We're going to jump around a little in this window as certain parameters will significantly improve your performance more than others, and it's best to start there. The first option that can significantly improve the performance is the UI refresh rate, which is down at the bottom of the Performance tab. Set it to 30 Hz unless you specifically need it set to 60 Hz, and you should always use OpenCL GPU acceleration, which should be checked by default. Limiting your input to 1080p will downscale the input signal to fit into a 1080p raster size if the source's original frame size is bigger than that. In this case, you'll always monitor a 1080p signal regardless of the original source's resolution. Scaling your input signal to the scope's viewer size will have an impact on performance as well, especially when using a lot of scopes in your layouts. This option will basically scale down the source's raster dimension to a size where the scope can actually utilize the pixels to render out the image in the scope. A perfect example of this is if you're trying to view a 4K input signal and every pixel from it. Once it's scaled down into the scope, most of the pixels will basically overlap in the scope's display. This option will allow the scope to sample less source pixels, improving your overall performance. Depending on the CPU-GPU combination you have, toggling the Do the Scaling on the CPU option, assuming that your source type is supported for CPU scaling, will really take the load off your GPU and increase your system's overall performance. And finally, the scope's resolution scale, if set to anything less than 100%, will be rendered out in that lower resolution. Every input source has its own input frame scale. Please keep in mind that some of the input sources might need to be restarted to apply this setting. Something important to keep in mind is that this will affect the QC gamut check. If you require the gamut check precision, please keep this option set to 100% Otherwise, the gamut check will be calculated on a downscaled image, which might give you false results. If you monitor SDI HDMI signals, you can change the signal resolution in your host application like DaVinci Resolve, Premiere Pro, or Scratch, and then OmniScope will get the lower resolution signal to begin with. One last thing that's important to mention is that altering the signal's depth between 8, 10, and 12-bit in your host application will have no performance impact on what you're seeing inside of OmniScope. Alright, that wraps up our look at performance. In our next lesson, we're going to talk about working with multiple inputs inside of Nobe OmniScope.